this screencast, we're going to walk quickly through the GCD program and see if we can understand better how it works. I'm going to load it from the example, and I'm going to take in the assembly window so I can actually see what it looks like. I'll load from memory, disassemble it, and now I can see the code over here in this window. The other thing I'm going to do is bring up the log window, which will actually tell me each instruction as it's executed. So with that, let's see if we can figure out what's going on with this program. The other thing I can do is I can toggle between binary and regular numbers here. Binary is very handy to figure out what an instruction is, but if I'm looking for data, I may find it easier to read in decimal. So, let's take the first step and execute the load 14 instruction. You can see that here on top of the assembler window. That should load the contents of memory cell 14 into the accumulator. And sure enough, it did. You'll notice in the log window, it shows us that action, the instruction address, the instruction itself, and the current contents of the accumulator. Let's run the next instruction, sub 15. This subtracts the contents of 15, or 24, from the accumulator, leaving with -6. The next instruction is a jump 0 instruction. It's only going to jump if indeed the result in the accumulator is 0. So this instruction should just continue on. Sure enough, we're now at location 3, which is a jump of negative instruction. What's in the accumulator is negative, so we should see this jump down to location 6. Watch the program counter arrow over here as we execute this jump instruction. There it is, now ready to execute instruction in memory location 6, which is a load 15. We'll load 15, contents of 15, into the accumulator, and the next instruction subtracts 14 from it. So it's actually exactly the same subtraction, but in the opposite order. Load 14, subtract 15 gave us -6. We didn't like a negative result, so instead we redid it by loading 15 and subtracting 14, leaving with a +6. We're now going to replace the large number in 15 with this new result. That's Euclid's algorithm, which you may have learned about way back in 9th grade. And sure enough, we've replaced that large number down here in location 15. Now we're going to jump back to location 0 and basically execute this same set of instructions all over again, but now instead of having 24 and 18, we have 18 and 6. Load 14, which is the number 18, subtract from memory location 15, and that leaves us with 12 in the accumulator. It's not 0, so we continue. It's not negative, so we continue. And we store that result, 12, in memory location 14. And guess what? We go back and do it all over again, now with 12 and 6 in those memory locations. Load 12 from location 14, subtract 6 from location 15, and we're left with 6 in the accumulator. It's not 0. It's not negative. So we store that in location 14 and jump back for another bite of the apple. Load the 6 from memory location 14, load the subtract 15, which is also a 6, and that leaves us with 0 in the accumulator. Jump 0 now will happen, and we'll jump to memory location 10, which is the stop, and the program is over. So we're left with the GCD in those two memory locations, 14 and 15, and actually as a result, byproduct of the computation, it's also left up here in the temp register inside the CPU.